Good morning, children. Children, today we do chapter 2, Power Play, in which we learn about exponents and very interesting facts related to exponent in our daily life. So let's start. First, we have exponent and power. An exponent shows how many times a number base is multiplied by itself. So here a raised to the power n. A is called base, n is called exponent, and exponent is also known as power. So a raised to the power n means a multiply n times. Next we have laws of exponent. Product of powers. A raised to the power m multiply a raised to the power n. Same base, then exponents get added. Quotient of the power having the same base. So a raised to the power m if divided by a raised to the power n. In case of division, we subtract the exponent. So we write it as a raised to the power m minus n. Power of a power. A raised to the power m raised to the power n, it will become a raised to the power mn. Means exponents get multiplied. Power of a product. A raised to the power n, b raised to the power n, it can be written as ab raised to the power n. Means raised to each factor. Power of quotient a upon b raised to the power n, it is written as numerator raised to the power n, denominator raised to the power n. That is a raised to the power n upon b raised to the power n. Zero exponent, any number exponent 0, value is always 1, except a is equal to 0. Negative exponent a raised to the power minus n, it is written as 1 upon denominator a raised to the power n. So negative exponent always written as 1 upon a raised to the power n. Then fractional exponent, if we have a raised to the power m upon n. So we write it as nth root of a raised to the power m. Nth root of a raised to the power m. If n we write here 2, we write square root of a raised to the power m. If we write n3, we write cube root of a raised to the power m. Exponent of 1 and 0. Now 1 raised to the power n is always equal to 1. 0 raised to the power n is always equal to 0. N should be greater than 0. Now exponent of negative base. If base is negative and exponent is even, then we get positive answer a raised to the power even exponent. If negative exponent has the negative base has the odd exponent, so we write minus a raised to the power odd. So if we have exponent even, then we get positive result. Answer will be positive here. And if we take odd exponent, then answer will be negative here. Similarly, we take for minus 1 raised to the power n. Minus 1 raised to the power n, if n is an odd number, then minus 1 raised to the power odd, it will give the negative result. If n is even number, then minus 1 raised to the power n will become plus 1. For example, minus 1 raised to the power 5 is equal to minus 1. Minus 1 raised to the power 56 is equal to 1. 56 is an even number, so 1 is positive. 5 is odd number, so 1 is negative. Now minus 2 raised to the power 4. 4 is even number, so minus 2 multiply 4 times. Now minus 2 multiply by 4 times. First we do multiply minus 2 into minus 2. It becomes minus and minus 2 minus give plus. 2 2s are 4. Similarly minus 2 multiply minus 2 4 and it will become 16. So minus 2 raised to the power 4 will become 16. Now let's do about this power line. That if 7 raised to the power 7, it means 7 multiplies 7 times. So when we multiply 7 times, we will get 8,23,543. And if we divide this by 7, so 7 raised to the power 7 means divide by 7 will become 7 raised to the power 6. And 8,23,543 divided by 7, we get 1,17,649. So at every step, we divide by 7. So 7 raised to the power 6 divided by 7, we get 7 raised to the power 5. And 1,17,649 divided by 7, we get 16,807. 7 raised to the power 5 divided by 7, 7 raised to the power 4. And 16,807 divided by 7, we get 2401. Then again divide by 7, we get 7 cube, and 2401 divided by 7, we get 343. 7 square, 49. Then 7 raised to the power 1, we get 7. Now 7 raised to the power 0. 7 divided by 7, we get 7 raised to the power 1 minus 1, that is 7 raised to the power 0. And 7 divided by 7, we get 1. Now 7 raised to the power 7 divided by 7. So we get here 0 minus 1, that will become 7 raised to the power minus 1. And negative exponent value is written as 1 upon 7. In this way, if we divide it again by 7, so it will become minus 1, 7 raised to the power minus 2. And this will become 1 upon 7 square, and 1 upon 7 square is written as 1 upon 49. Similarly, 7 raised to the power minus 3 is written as 1 upon 43. 7 raised to the power minus 4 is written as 1 upon 2401. Now in power line, if we multiply 2401 by 49, we get it as 117649. And 2401, it is taken as 2401. This is taken as 7 raised to the power 4. And 49 is taken as 7 square. So 7 raised to the power 4 multiplies 7 square is equal to 7 raised to the power 6. And if you look at the number line, power line, we see 7 raised to the power 6 is 7 raised to the power 6 is 1,17,649. Similarly, 49 cube is equal to 1,17,649, because 49 can be written as 7 square raised to the power 3. So 7 square raised to the power 3, 7 raised to the power 2 raised to the power, we get 2 multiply 3, 7 raised to the power 6. In this way, 16,807 divided by 49, you get 343. And 16,807, it is 7 raised to the power 5 divided by 7 square. So 7 raised to the power 5 divided by 7 square, exponents get subtracted. 5 minus 2, we get 7 raised to the power 3. So now let's try to understand about exponential growth, power of growth. So here is the example of magical pond. In the middle of a beautiful magical pond lies a bright pink lotus. The number of lotuses double every day in this pond. After 30 days, the pond is completely covered with lotuses. On which day was the pond half full? So day 1, there was only one lotus. So it is 2 raised to the power 0. One lotus means 2 raised to the power 0. Day 2, it become double, means 1 multiply by 2. So it will become 1 multiplied by 2, it will become 2 raised to the power 1. Day 3 will become 2 raised to the power 2. Day 4 will become day 2 raised to the power 3. So what we are observing, day 1 has 2 raised to the power 0. Day 2 has 2 raised to the power Day 2 has 2 raised to the power 1. Day 3 has 2 raised to the power 2. So we are getting first day exponent 0, second day exponent 1, third day exponent 2. So day 29 it will be 2 raised to the power 28. And day 30 2 raised to the power 29, and on day 30 this magical pond get fully covered. So half covered in 2 raised to the power 28 days, and full covered will be in 2 raised to the power 29 in 30 days. The next we are doing Roxy outfit. Now Roxy has 7 dresses, 2 hats and 3 pair of shoes. How many different ways can Roxy dress up? So first we can take here purple hat. Can wear with all 7 dresses. So here we have the 7 ways. Then pink hat can be wear with all 7 dresses. So if we have to wear hat and dress, we have 7 multiplied to 14 ways. Either you can write 7 plus 7, 14 ways. Now Roxy have to wear 3 pair of shoes. So how many combination can be made here? So now if we take purple purple hat, 7 dresses, and then we can take 1 pair of shoe. In the same way, purple dress, 7 dresses, blue pair of shoes. Then purple dress, 7 Roxy has 7 dresses, 2 hats, 3 pair of shoes. Now how many combinations she can make? If she wear purple hat, she can wear any one dress from the 7 dresses. If she wear pink hat, she can wear any one dress from the 7 dresses. So there will be 7 combination with purple hat and 7 combination with pink hat. So if she have to make the combination with hat and dress, there are 14 combination. But she also have 3 pair of shoes and she have to make the combination with this. So total combination will become 7 multiplied 2 multiplied 3, 42 combination. Next we have a safe lock that has 5-digit password. Each digit can be 0 to 9. There are 0 to 9, there are 10 choices for each digit. So if we have to choose first digit, that have the option 10. Second digit, again we have the 10 option. So 10 multiply 10. Third digit option is again 10. Fourth digit option is again 10. Fifth digit option is again 10. So there exists 10 raised to the power 5 combination. So that is written as 1 lakh password. Now if we have to make 6 letters lock, in the previous part we have done the digit lock. Now we have letter lock. Digit we have 10 from 0 to 9. But letters we have 26 choices. So first letter if we have to choose, we can choose it in 26 ways. Second letter if we have to choose, again 26 way. Third letter we have to choose 26 ways. Fourth letter we have to choose 26 ways. So in this way we have 26 multiply 26 6 times ways. So 26 raised to the power 6, that is 308,915,776 passwords. Now let's learn how the real life codes get generated. PIN codes in India, these codes are postal index number, and these numbers have 6 digits, where first digit refer to the region. There are 9 regions. Out of that 9 regions, from which region this first digit belong. Second digit, it represents sub-region. Third digit represent district, and last 3 digit represent the specific post office. Theoretically, there are 10 raised to the power 6 combination, and practically only valid codes based on the geography and postal infrastructure. As children, we have the code 132001. So 001 represent the post office from which it belong. 2 represent district. 2 represent here district, and 3 represent here sub-region, that is Haryana, and 1 represent here region. Now if we have to make the combination for mobile numbers, that has the 10 digit, and these numbers are given by the telephone department. So how they give the numbers? Let's see. The structure is given that first digit, that will be either 6 or 7 or 8 or 9. First digit is fixed from 6, 7, 8 and 9. And remaining 9 digit can be taken as any one from 0 to 9. So for the first digit, there are 4 combination, and for the rest 9 digit, there is 10 raised to the power 9. So here total number of combinations are here 4 multiply 10 raised to the power 9, that is 4 billion possible mobile numbers are here. And if we have the prefixes 91, 98, these are given by different telecom operators. Next we have vehicle registration number. For example, it is given DL01AB1234. So DL, it represents the state. 2 letters, it represent state or UT code. Then we have the 2 digits. It represent RTO code. Next we have 2 letters. That is the series of the number. And 4 digit, it is the unique number of the vehicle. So combination per regional transport office is for first to 26 raised to the power 2. Then next 2 digit can be written as assigned by RTO. RTO means Regional Transport Office. And then 1, 2 letters is the series, and last 4 is the unique number of the vehicle. So combination will be here. First 2 letter for the state combination, it can be written as 26 raised to the power 2, and last 4 digit 10 raised to the power 4. So here we have 676 multiplied by 10,000 combinations. These combination managed by Ministry of Road Transport and Highway via Parivahan portal, and some important or fancy numbers can be bid for and are priced higher. Now, if we look all these examples, we see that these all examples represent the exponential growth. So, if we have to add 10 rupees in our piggy bank daily, so it will become 20 on second day, 30 on third day, 40 on fourth day, and 10th day it will become 100. So this is called linear growth. Linear growth means the same number is added every time. Now we have exponential versus linear growth. Linear growth increase by the same amount each time. And linear growth rule is mx plus c, means this c amount is added every interval of time. In exponential growth increases by the same factor each time. Same factor means it get multiplied each time. So here exponential growth is represented by a multiply b raised to the power n. So in linear growth, we are taking here 500 rupees saving added every month. So in the first month it become 500 rupees. Second month it become 500 plus 500,000 rupees. Third month it become 1500. Fourth month it become 2000. Fifth month it become 2500. So there is the linear growth. It is in the straight line because 500 rupees added every month. And if we look at the exponential growth, that bacteria doubling every hour. So 0 hour, when it gets started, bacteria was 1. Then after 1 hour, it become 1 multiplied by 2, it become 2. Second hour, 2 multiplied 2, it become 4. Third hour, it become 4 double 8. Fourth hour, it becomes 16. Fifth hour, it becomes 32. So it is increasing at the rate a multiplied 2 raised to the power n, where a is the initial number from where it gets started. So when we draw the graph, this exponential growth has the rapid increase. So linear growth means add and exponential growth means multiply. Now this is the scientific notation. Scientific notation is a way of writing very large number or very small number using power of 10. This is the standard form of the number, that is written a multiply 10 raised to the power n, where a is greater than or equal to 1, less than by 10. A is called the coefficient. N is an integer. It may be positive, it may be negative. For very large numbers, n is positive, and for very small numbers, n is always negative. So, for very large number, move the decimal left to get the number between 1 and 10. Count the place moved, that is n, as it is given 96 with 6 zeros. So now we have to move the decimal between 1 to 10 to the left side. So from here we are removing decimal after 9. So it will become 9.6. And how many digit under this curve? That is 7. So 9.6 multiply 10 raised to the power 7. For very small numbers, n is negative. Means if the number is less than by 1, it will give the negative exponent. So move the decimal right to get a number between 1 and 10. So right side we have to move the decimal after 4. So it becomes 4.2 multiply 10 raised to the power 5 digit under this curve. So we write